In this video, we'll show you how to use transfer path analysis software. It's part of SimCenter Test Lab. It's a member of the Acoustic family of products. We'll start up the transfer path analysis. Once the software is started, I'll open a project that has some FRF and operating data that I've already gathered, and I'm going to combine this data together in order to do a transfer path. In here we have several FRFs, all to the same microphone location. Perhaps that's an operator ear where we have some unwanted noise. And these all come from several different attachment locations between the source and the structure. I have some operating data on the active side of some engine mounts. And then I also have some operating data, third order, on the passive side of some mounts. I also have some mount data, and these are the mount stiffnesses at these different attachment locations. I'm going to take all this data, put it in the input basket, go to TPA model here, and then sort it out a bit. The operator ear microphone is of great interest, so we have that as a target. I have several paths I'm interested in. In this case, I have 15 paths, but there's 3 directions. So in reality, we have 5 attachments that we're evaluating between our source and the receiving structure. This same data, I didn't measure forces directly, so I have accelerometer measurements on each side. I also have the corresponding active side here, so I'll select that. And these are indicator measurements. Indicator meaning indirect measurements, not force directly, but acceleration, that I'll use to derive the force. I can read the input basket here for the operational data. I'm interested in third order. That's my operating condition of interest. And then I'll grab my passive side directions, and I'll also grab my active side, match those up. And then I can go to FRF selection here, read from input basket, and it finds any corresponding data that I selected that corresponds to the IDs in the TPA model definition. And you can see I found FRFs. It turned green here. In fact, I have 15 FRFs for these paths. If I take a look at the legend here, it looks like this big FRF, body 1Z, stands out. Does not mean it's the dominant path. That'll also depend on the operational data and the forces that are coming in there. Of course, I have to calculate those forces still. I mainly have accelerometer or acceleration measurements at these path locations. I go to TPA loads here, mount stiffness, and from this input basket, I can read in all the mount stiffness data. I'll select the paths of interest that I want to read in the mount data for, hit search mount stiffness, they all turn green. Again, I'll highlight them again, and I'm going to use these mount stiffness calculated forces, which I can see right here, as my inputs into my model, and I can check them all out here. So I've calculated my forces. Now I'll go to TPA results here. I'm interested in looking at that third order. I'll update the display. I'm kind of partial to this contribution display. And we can see that we do have measured and calculated totals that have a similar spot. And the calculated total, we can see we have one dominant path, body 1Z, right around 4,600 RPM up to about 5,000 RPM. So body 1Z seems to be driving the operator ear. We can diagnose that a little further with this path-specific display. I can take a look at each individual path, see my calculated total here and my measured total, which match pretty well. I can see the contribution of body 1X to that total. It's a lot smaller. That contribution is composed of the FRF for that path times the forces for that path Those forces are derived from the mount stiffness multiplied by the acceleration on both sides of those mount. If I look at body 1Z, you can see that the FRF is indeed big, but we also have a corresponding increase in the force. If I compare that to 1Y, force is a lot smaller, FRF is less sensitive, hence it's not a big contributor. Body 1Z though, you can see that both the FRF and the force are large contributors. And that's how you use transfer path analysis. Thank you.